Imagine if someone came up to you and challenged everything you know by saying that all creation, from Mount Everest to the Eiffel Tower, is made from one thing and one thing only: strings. Crazy, isn't it? Well, that happens to be the essential idea behind string theory. And to truly understand string theory, we're going to be looking inside a bucket of water. If we zoom in far enough, we'll see molecules, which are far from the end, as if we go even further, we'll see atoms, which are in turn made up of electrons, protons, and neutrons. If we zoom in to even greater in extent, we'll arrive at tiny vibrating structures known as quarks. This is where conventional knowledge comes to an end. But string theory goes a step further by stating that within these particles there are tiny, string-like filaments of energy that are constantly in a state of vibration. But the true elegance of string theory lies in the fact that different string vibrations create vastly different particles, analogous to how different string vibrations in a harp produce distinct notes. So in theory, a hydrogen atom and a helium atom would be made from the same entity, strings. The only thing differentiating them would be the vibrational tendencies of the strings from which they are constructed. Okay, it's an elegant theory, but why is it that scientists are turning their backs on everything they know to embrace this one? Good question. Modern physics rests on two pillars: quantum mechanics and the general theory of relativity. The problem is that one looks at large bodies which are heavily influenced by gravity, and the other looks at subatomic particles which are virtually unaffected. To exacerbate this issue, every fundamental force apart from gravity is thought to be caused by certain subatomic particles. Now, if we postulate the existence of particles that transmit gravity, gravitons, and hypothetically collide them with each other, we arrive at an error, which is that an infinite amount of energy is created within an infinitesimally small space, which is mathematically irrational. This is where strings come in. Due to the amorphous, indefinite nature of strings, these collisions are possible, as these strings allow for such mathematically extreme values. Unfortunately, there are two underlying issues with string theory. Firstly, the maths for string theory only works in a 10-dimensional space. And second of all, there is no known practical way to test for its existence. To tackle the problem of extra dimensions, scientists have stated that they do indeed exist. However, we don't see them, as they're minuscule, shriveled up, and embedded into our three spatial dimensions. As for the practicality of string theory, if we observe string vibrations by recording particle collisions, express them as equations, using which we obtain values that match with what's been conventionally proven, then string theory will be the unified notion that governs our universe in its totality. It will be the theory of